Okay, what are the most number of solutions that you could imagine for a linear quadratic system? Meaning, one of the linear means the shape is a line. The quadratic means the shape could be parabola, circle, or ellipse, circle, or it could even be like a hyperbola, which is the inverse variation. 2 is the most. It could be 1. It could be 0. Can't be more than 2. Do you have a question there, Peter? No. Does that sum it up? Yes, good. All right, so here's a intersection of a parabola and an ellipse. How many solutions do you see there? So here's a solution, here's a solution, and here's a solution. Sometimes one of the common mistakes that students do when they're looking at a system, a graph of a system, is that they'll start to think like, that's a solution, or any x-intercept is a solution. That's what you do with polynomials, right? If you're graphing a polynomial to solve a polynomial equation, you graph it and then you look for the x-intercepts. But that's not what we're looking for here. We're looking for these intersection points. So definitely it's got 3. And then you could estimate them visually. I mean, this one is pretty easy, right? What is that point? -4, +2. Right? How about this one? This one we definitely have to estimate. Right? The x is in between -2 and -3, maybe a little closer to -2. -2.3, something like that. How about the y? It's in between 0 and 1. Point. How about 0.4? And then what about this one right there? What does it look like? X is -2. That's easy. How about the y? 1, 2, between 3 and 4, maybe 3 point. I think it's a little higher than the middle, but I don't think they're not going to give you like something like this and have one answer which is -2, 3.6, the other was -2, 3.7. Like anybody could really be that precise from looking at it.
They gave you a little